Hello friends, welcome to EPG Pathshala. Today we are going to discuss statistical tests and measurements. This lecture is a part of your paper on communications research. Mathematical science dealing with the collection, analysis, interpretation and presentation of numerical data in order to draw appropriate conclusions is called statistics. It is an independent branch and its use is highly prevalent in all the fields of knowledge. Methods such as parametric and non-parametric tests are used in statistics. Statistics is used both in scientific and non-scientific way to make appropriate decisions and conclusions based on the data. Statistics which are based on the normal distribution of the data are called parametric statistics. T, Z and F are examples of parametric statistical tests. Those statistical tests which are not based on normal distribution of the data are called non-parametric statistics or distribution-free tests. Chi-square test, Spearman's rank correlation coefficient, Mann-Whitney U-test, Kruskal-Wallis analysis of variance, etc. are some of the examples of non-parametric tests. Furthermore, parametric tests are more powerful statistical tests than non-parametric tests. It is always recommended to use parametric statistical tests than non-parametric tests. However, non-parametric statistical tests are only used when the assumptions of the parametric tests are not met or fulfilled. Assumptions of parametric and non-parametric tests. Assumptions of parametric tests are: the distribution of the sample should be normally distributed. The sample is in the form of interval or ratio scale. The observation must be independent. The populations must have the same variance. The samples must have equal or nearly equal variances. When the assumptions and conditions of the parametric statistical procedures are not met, in such a situation we are bound to use non-parametric statistics. Non-parametric statistics are used in situations if the sample is not normally distributed, if our sample data has been measured at nominal or ordinal scale, the sample size is very small. Trakowski in his research paper mentioned that wrong statistical tests are used by the researchers. He reported that most of the researchers use parametric tests which does not fulfill the assumptions of parametric tests and vice versa. Nowadays, the availability of the different types of statistical softwares like SPSS, Amos, MATLAB, R, etc. makes performing of the statistical tests easy, but selection of the appropriate statistical test is still a problem. A systematic step-by-step approach is the best way to decide how to analyze the data. Hence, it is recommended to follow certain steps before analyzing the data. These are: identify the research question. Frame the question in the form of a statistical hypothesis such as the null hypothesis, no relationship between the variables, and alternative hypotheses, positive or negative relationship between the variables. Determine whether the variable is dependent variable or independent variable. Use appropriate research design which controls the confounding variables. Use the appropriate statistical test. Do a power analysis to determine a good sample size. Collect the data. Examine the data to see whether it meets the assumption of parametric or a more appropriate substitute test. After this, apply the statistical test you choose and interpret the results. Then, show your results effectively, usually with a table or a figure. T-test. A statistical test that offers an opportunity to compare between two group means is called t-test. For example, if we want to compare between male and female on health issues, or if we want to compare between rural and urban people on the same, t-test is the appropriate statistical test to measure the difference between these groups. Other statistical tests include an z-test, chi-square test, and analysis of variance. T-test is used when we have smaller group of data, while a z-test is used when we have greater group of data, normally more than 30. It verifies if the difference between two means is larger than would be expected by chance. Common types of t-tests which are frequently used are dependent sample t-test and independent sample t-test. Let us discuss this in detail. Dependent samples t-test, a statistical test which is used to compare between two sample means on a single variable. Dependent variable is called dependent sample t-test. In this, the participants are meaningfully related with each other as the participants are same in both pre and post test. Unlike independent sample t-test, dependent sample t-test is used to compare the mean of a single sample or paired samples. For example, if a researcher is interested to compare the mental health of the participants before and after the national disaster such as earthquake, tsunami, etc., he will first administer the mental health inventory on a group of participants before natural disaster. The same group of participants then participates in the study after the tsunami. Then the researcher can compare the two means. In the dependent sample t-test, each score is matched, and because of this matching, the researcher can predict that the scores are interdependent. For such kind of study, dependent sample t-test is the appropriate statistics. Independent sample t-test. Independent sample t-test is used when we have to make a comparison between two sample means whose means are not dependent on each other. Unlike dependent sample t-test, where the participants are meaningfully related with each other, two separate groups of participants participate in the study. One of the commonly used t-test is the independent sample t-test, where the groups are completely independent of each other. Comparison between male and female, urban and rural areas is the simple example of independent sample t-test. If we want to make a comparison between male and females on mental health, an independent sample t-test is the appropriate statistics. In this test, the sample of men should not be related to the sample of females, and there should not be any kind of overlap between the two groups. That is, the groups should be independent of each other. Assumptions of t-test. The common assumptions made when doing a t-test includes the scale of measurement should be continuous or ordinal in nature. The data should be selected through probability sampling technique. The data should be normally distributed. and the sample should be adequate. Z-test. Like t-test, Z-test is a statistical test that offers an opportunity between the two groups, but unlike t-test, where the variance is unknown and sample size is small, the Z-test, there is known variance and sample size is larger. For example, if we want to compare between male and female on mental health, Z-test is the appropriate statistical test to measure the difference between the groups. The condition is that the data should be greater than 30 and normally distributed, and the standard deviation should be known. Besides that, while conducting a Z-test, the null and alternative hypotheses alpha and Z score should be stated. Assumptions of Z-test. There are some basic assumptions of Z-test as well. The sample must be independent of one another. The samples must be normally distributed. The sample sizes must be large or equal to 30. Population variance and the standard deviation should be known. Analysis of variance, ANOVA. Let us now discuss analysis of variation, ANOVA. While the t-tests and z-tests are used when we have to compare the differences between the two groups, the problem arises when we have to compare more than two groups. In such a situation, when we compare among three or more than three groups, analysis of variance is an appropriate statistics. It is an extension of t-test and z-test. It is better to say the technique as analysis of means rather than variance, as inference about the means are made by analyzing the variances. This test is used to test general rather than specific differences among means. While performing analysis of variance, we get two variances, between group variance and within group variance. Difference between the means is called between group variance, and difference within the means is called within group variance. If the difference between the two group variances, that is between and within groups, is significant, that is between group have large variance as compared to within group, we reject the null hypothesis and conclude that our experimental manipulation had a real effect. If the difference between the variance is not significant, we accept the null hypothesis and conclude that experimental manipulation didn't have real effect. Unlike t-test, where we get the t-value, in analysis of variance, we get the F ratio. The F ratio is computed by dividing the group's variance estimate by within group variance. There are different types of ANOVAs, such as one-way ANOVA randomized, one-way ANOVA repeated, two-way ANOVA randomized, and two-way ANOVA repeated, and also factorial ANOVA. A one-way ANOVA is used whenever we have one independent variable with three or more than three levels. If separate groups of subjects participate in each condition or level in a between subject design, a randomized ANOVA is the appropriate test. However, if the same subjects have participated in each condition in a within subject design, a repeated measure ANOVA is the appropriate test. While a two-way ANOVA is used whenever two independent variables are manipulated and all the combinations of levels of each of the two variables are used. When we have one continuous dependent and two or more categorical independent variables, the factorial ANOVA is the appropriate statistics. Besides mean difference, factorial ANOVA provides the main as well as the interaction effect. For example, if we want to know the difference between the boys and girls on academic performance in school. Further, we also want to know the difference between the children coming from rural and urban areas on academic performance. In this example, the academic performance is the dependent variable and gender of the children and area of location, rural or urban, are two independent variables. This is known as two gender, two location factorial analysis. Assumptions of analysis of variance, ANOVA. The common assumptions made when doing a ANOVA test include: the sample should be drawn from a normally distributed population. All populations should have a common variance. All samples should be drawn independently of each other. Within each sample, the observations are sampled randomly and independently of each other. Difference between T, Z and F test. So, what is the difference between T, Z and F test? Z test is used to compare the mean of two groups with large sample size and whether population standard deviation is known or not, while as t-test is used to compare between the two groups when the population standard deviation is not known. An f-test is an extension of t-test and z-test and is used to compare mean score of more than two groups and population variance of any sample size. Chi-square test. Chi-square test is used to determine the difference between expected frequencies and observed frequencies in one or more than one categories is called a chi-square test. It is one of the most commonly used non-parametric tests used by social science researchers. The chi-square test is a statistical test which measures the association between two categorical variables, Ugona and Walker 1995. It is a computationally simple statistical test which is used to examine independence across two categorical variables. Chi-square performs two important functions. Goodness of fit. Chi-square test provides us a statistical model which is used to describe how well it fits the observation. It is used to compare the observed values with the expected value. In this test, the data is first divided into intervals and then points that fall in the intervals are compared with the expected points in each interval. Measure of independence. One of the most useful statistics for testing the hypotheses when the data are nominal is the chi-square test of independence. It is used to determine the significance of association between the two variables or categorical variables when the sample size is large. This test is used when we have to compare two nominal or categorical variables and we want to know the difference in terms of proportion between the variables. For example, chi-square test of independence is used to determine whether gender is related to voting preference. According to Kothari, chi-square test is simply a technique of association between two attributes. It evaluates the probability that the observed relationship results from chance. If the calculated value of chi-square test is less than the tabulated value, we could conclude that the two variables are not related with each other. If, however, the calculated value is greater than the tabulated value, then we could conclude that there is a significant association between the variables. Assumptions of chi-square test. There are some basic assumptions for chi-square test as well. The data should be quantitative in nature. It should have one or more categories. Each observation should be independent. The sample size should be adequate, and no cell should be having an expected frequency of less than 5. Data should be in frequency form, and all the observations must be used. Summary. Let us now try and summarize what we discussed in the text. In this lecture, we described the basics of parametric tests, t-test, z-test, and ANOVA, and non-parametric tests like chi-square test, and we hope that information provided has clarified the difference between parametric and non-parametric statistics, as well as the difference between independent sample t-test and dependent sample t-test. One-way ANOVA, two-ways ANOVA, factorial ANOVA, and chi-square test. We also discussed the assumptions of all the above mentioned statistical tests. Do attempt the question in the self-evaluate quadrant. For further reading suggestions, please refer to the third quadrant. Thank you.